Hi everyone, this is Mrs. J. Today we're going to be solving linear equations and inequalities and also talking about how to make equations of linear functions. But first, I have a warm-up for you guys, so please pause the video and give it a try. All right, go ahead and check your work here. There's lots of different ways you could approach this problem. Maybe you distributed first. However, if I ever see fractions within a linear equation, I'm always going to clear them first. I don't like working with fractions, so if you multiply both sides of your equation by your LCD, so if you have 2 and 3, your LCD would be 6. Notice it clears your fractions, just making it a little bit easier for us to work with. And you don't need to do that, but you'll probably notice throughout the year, that is what I will do. I will always clear the fractions by multiplying both sides by the LCD. And our final answer is 135 over 4. Let's get in the habit of using simplified improper fractions unless otherwise noted. All right, so today we're going to be working with different forms of linear equations to start. Here we have a linear equation that has a lot of different variables, and it's very common for us to want to solve for a given variable in an equation. So this is actually the formula for the area of a trapezoid, and we want to solve for h. That means to isolate it. So we need to move everything else to the other side. We could start by multiplying both sides by 2. And now anytime we have a factor, so these are two factors, h and a plus b are being multiplied, we can divide away the entire factor. So I'm just going to divide both sides by that a plus b, and we have 2a over a plus b. And that has allowed us to solve for h. So this is going to be useful when we're working with different formulas, and maybe we want to find the height of a trapezoid given the other pieces of information. We can rewrite first and substitute what we know. All right, I want you to try one on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So here we want to isolate the b, so I moved over the a and then I divided by 2. You can leave your answer like this. If you'd like, you can divide each term in your numerator and write it like this. Either way is completely fine. All right, so now we're going to see if we can practice setting up our own linear equation given pieces of information and see if we can use that to help us answer a question. So this says the diameter of Earth, I'm going to highlight important information, is 828 kilometers, less than twice the diameter of Mars. And then it says Earth has a diameter of 12,756 kilometers, and they want us to find what is the diameter of Mars. So if we want to define the diameter of Mars, let's give it a variable. Let's say the diameter of Mars, let's call it m, and I'm going to call the diameter of Earth E. And I'm going to start by using these variables, and then I could substitute anything we know. So it says the diameter of Earth is, so that would mean that we write E equals, anytime you see is, we write equals, 828 kilometers less than twice the diameter of Mars. So first we need to start with twice the diameter of Mars, so 2m, but the diameter of Earth is 828 kilometers less than this, so then I'm going to subtract away 828. So we know for this problem, they're asking us to solve for the diameter of Mars. So I'm first going to isolate that m variable. So we have 2m equals e plus 828. So m equals e plus 828 divided by 2. And then we can substitute what we know to be Earth's diameter, which is 12,756 plus 828 over 2. And then all we need to do is use our calculator to do this. If you're plugging it in exactly as you see it, you have to group your numerator in your calculator. If you don't, your calculator will only divide 828 by 2, but we want to divide the sum of these two numbers by 2. So just be careful that you actually have those parentheses So you can plug it in all in one shot. And here we should get 6,792. And then, of course, we're going to use our units for word problems like this. So notice for this type of problem, I define my variables. That's something I definitely want you to get in the habit of doing. I set up an equation and then I solved. All right, I have one for you to try on your own, so please pause the video and hit play when you're ready to check. All right, go ahead and check here. They are asking us to find how many field goals he made, so I defined the number of field goals as X. You could use whatever variable you want. So the total points is 100, and that was comprised of the 28 points from free throws plus, and I did 2 times X because each free throw is worth 2 points, and that allows you to solve for X, and it should get 36 field goals. So now we're going to practice solving linear inequalities. So an inequality is a mathematical statement that has one of these following symbols. So either a less than or equal to, a greater than or equal to, or you could have a not equal to. So it's essentially, it looks like an equation, but instead of an equal sign, it has one of these different symbols. So we're going to solve inequalities just like we would solve an equation, except we need to remember this really important rule. When you multiply or divide both sides by a negative number, we have to make sure we are flipping our inequality sign. So other than that, we're using those same properties to help us solve for our variable, but you do need to watch out for multiplying or dividing by that negative. And then for these problems, we're going to express our solutions either using set builder notation or interval notation, but we can also show them graphically on a number line, which we will practice doing as well. All right, let's give this first one a try. So here I'm going to start solving just like I would an equation. I'm going to subtract 12.9 from both sides. So we get negative 5.6n is greater than or equal to negative 84. Now in this next step, this is what we need to watch out for. I am dividing by a negative number. So when I do that, I need to make sure that I flip my inequality sign in my next line. So that should give us n is less than or equal to 15. So this would be our answer in algebraic notation. Notice that we do want set builder notation for this one, just to practice. So we would say n such that n is less than or equal to 15. And then we're also going to graph it on a number line. So for this one, just give yourself a little number line. Give yourself just a couple tick marks. And this does say n is less than or equal to 15. So if you'd like to show a couple of the other values, you can. Since it is less than or equal to, we'll do a closed coordinate like this. And then we're going to do everything below it. And then we'll add the arrow pointing to the left. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. You'll notice for this one, the way that I went about solving it, I didn't multiply or divide by any negative, so I didn't need to flip my inequality symbol at any point. You should end up with p is greater than or equal to negative 7. So in interval notation, that would look like this. And then here's the graph on the number line. So here we're going to see how we can set up an inequality, kind of like we did before with an equation, to help us solve a problem. So this says the daily recommended intake of calcium for teens is 1,300 milligrams. So it says that Chris gets 237 milligrams of calcium from a multivitamin that he takes every day, and then 302 milligrams of calcium from each glass of milk they drink. How many glasses of milk should Chris drink to meet this recommendation? So if you're meeting this recommendation, that means that you're getting 1,300 or more. So he's not aiming to get exactly 1,300, he's aiming to get 1,300 or more. So first we do need to define a variable. So since the problem is asking how many glasses of milk should Chris drink, I'm going to say G equals the number of glasses of milk. So that 237 milligrams from the multivitamin, that's just kind of a constant. He's going to get that amount plus, and then we have 302 milligrams from each glass of milk. So we'd say 302 times G, however many glasses they drink, and that needs to be greater than or equal to 1,300. So here we've set up our inequality. So now we just need to solve. So we could say 302 G is greater than or equal to 1,063, and then G is greater than or equal to 3.5. So we can kind of interpret what this means, and it would really be 3.52 if I'm rounding a little bit farther out. So this means that essentially Chris needs to drink a little more than 3.5 glasses. So maybe you want to write your answer like that, or maybe you want to say, well, Chris is only drinking full glasses. So that means that he would need to drink, Chris needs, well, we could say at least 3.5 glasses of milk. Or maybe we want to say, that's one way we could answer, or we could say that Chris needs 4 glasses of milk. Right? We would always want to round up for this because if we rounded down, then Chris wouldn't be getting enough calcium. So it really depends on how you want to look at it. If in your mind you think it's possible for someone to drink a half glass of milk, which it completely is, we could write our answer like this, but maybe if you want to just go for full glasses, then we would round up to 4 glasses. All right, so now we're going to talk about different ways to write a linear equation. So there's a few different forms of linear equations that we should know. The first one is called standard form. It is when your linear equation is in the form of ax plus by equals c. And there are a few stipulations to this. A needs to be greater than or equal to 0. So the coefficient of x should never be positive. And then it says A and B are both not 0. So it's okay if just A is 0. So if there's no x, that's fine. And if there's no y, that's also fine, but they cannot both be 0. And then A, B, and C are all integers, meaning they are not fractions. And the greatest common factor should be 1. So if you can reduce down those integers, you should. So this is a very specific way of writing a linear equation. You probably won't use it a whole lot, but it is good to know what standard form is. Now, slope-intercept form is going to be really useful for us. We've talked about this form before, y equals mx plus b, where m is the slope and b is the y-intercept. This is probably our most useful form when we're graphing, so we'd like our equation to be in this form. The next one is, I would say, the most useful form for creating an equation. You will use this form all throughout calculus, all the way up through calculus. So this is a really important one to know and remember and be able to use. So the equation is y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is just any point on the graph. So this form is really nice because it's a little more broad. All you need for this form is the slope and 1 point on your graph. If you're in slope-intercept form, it's the slope and it's that specific point, the y-intercept. So this is a really useful form for us when we're just writing a linear equation. And then this is going to be super important for us to remember today as well, that slope formula. So y2 minus y1 equal over x2 minus x1, which is essentially just rise over run, change in y over change in x. And for the slope formula, you do need to know 2 points on the graph. All right, let's give this one a try together. So here we are given a picture of a graph and we are going to write the equation and then rewrite our final answer in standard form. So in this picture, we can actually see all of the information we need. We can see that our y-intercept is 2 right here. So that means that our b value is 2. And we can also interpret what our slope is from the graph. So I'm going to just go between any 2 points that I know the coordinates for, and I can see that if I do rise over run, I'm going down 4 over 3. So that means that my slope is negative 4 over 3. So when I have those 2 pieces of information, I definitely want to use slope-intercept form to write this. So we have y equals negative 4/3 x plus 2. So now we want to write it in standard form. So x and y need to be on the same side, and x needs to have a positive coefficient, so I'll just add it to the other side. But also remember that a and b need to be integers, and c. So it's not okay for this to be a fraction, so I need to multiply everything by 3. So we have all integers. And notice I am multiplying both sides. So this would be my equation in standard form, but again, I am working from slope-intercept form here. All right, go ahead and give this one a try on your own. All right, go ahead and check here. So this is a pretty nice graph. Again, we can see what the y-intercept is, and we can see that our slope is 1 over 3. So I started from slope-intercept form, and then I moved stuff around and made sure that I was in that proper standard form. Now we do need to be careful when we're going from a graph. These were both really nice examples because we could clearly see what the y-intercept is, but if you don't see, if there's not a clear y-intercept, we're going to have to use point slope form to help us write the equation. So don't estimate what the y-intercept is, but if you see it in your graph, definitely use it. All right, let's try a couple more together. So here we're going to write an equation of a line in slope-intercept form that has these characteristics. So for this first one, it says it passes through the point negative 2, 4, and it has a slope of 5. So for this one, I don't have the y-intercept, but I do have an x1, y1, and I do have an m value, so I can use that point slope form. So y minus y1 equals m times x minus x1. So we have y minus 4 equals 5 times x plus 2. So notice that in the form, it does say minus y1 and minus x1. And now we do want to rewrite our final equation in slope-intercept form, but that's super easy to do. So we have 5x plus 10. So we get y equals 5x plus 14. So when you have this set of information, I definitely would like to see you guys using that point slope form and then rewriting it however you need to. Let's look at this next one. Here, we are just given 2 points. Well, I know that if we have 2 points, we can find the slope, which we'll always need to make a linear equation. So let's find the slope first. So let's do y2 minus y1. So minus negative 4 is plus 4. And then x2 minus x1. So our slope is going to be 12 over negative 4. So here our slope is negative 3. And once I have the slope, I can use either point. It doesn't matter which one I use. And then I can go back to my point slope form. So I'm just going to use this first one as x1, y1. So y minus y1 equals m times x minus x1, and then I'm just going to rewrite that in slope-intercept form. So y equals negative 3x minus 1. And there you have it. So please get comfortable using that point slope form. It's going to be super, super useful for you as you continue through multiple levels of math. And make sure you also know your slope formula. So if you're only given those 2 coordinates, you can start by finding the slope. All right, here I have one last one for you to try on your own. So please pause the video and give it a shot. All All right, go ahead and check your work here. So notice I started by finding the slope, and then once I had the slope, I just used this first coordinate in point slope form. Then I rewrote in slope intercept form. All right, that is all for today's video. Thank you so much for watching.